Okay, let's look at C5. So this practice C has to do with current. It says a total charge. Remember, we always want to write our given, and we want to write our find. So it says a total charge of 9 microcoulombs. So I'm going to write, millicoulombs, So little m is, so I'm going to write Q is equal to 9.0 millicoulombs, which is equal to 9 times 10 to the negative 3 coulombs. It passes through a cross-sectional area of nichrome wire in 3.5 seconds. So T is equal to 3.5 seconds. So it says find A, what is the current? So I want to find I. B, how many electrons, the number of electrons, in 10 seconds. And C, if the number of charges that pass through the wire doubles, what is the resulting current? So we want to find I if Q doubles. Remember, you want to chunk a problem. So what I want to do is I want to do one part at a time. So this is why it's important not to read the entire problem. And even though I wrote down my given and find, if you read everything at once, there's so many different things here, you'll get confused. So the first part says find the current. So what am I going to write down? Well, I know for practice C, I is equal to delta Q over T. Okay, and we want to solve for I. So I is equal to 9.0 is 10 to the negative 3 coulombs divided by 3.5 seconds. Okay, so then on my calculator, 9 EE minus 3 divided by 3.5 is equal to, now it has it not in scientific, but I'll put it in scientific because it's 0.00257 second 5. So it says 2.57 times 10 to the negative 3. And a coulomb per second is also called an amp. So that's part A. All right, part B, it says, I want to know the number of electrons. So let's think about this for a second. So I know I is equal to delta Q over T. Okay, so delta Q is equal to I times T. So this is the current. What's the definition of current? Current is what? The flow of electrons. So this is really the number of electrons times how many coulombs per electron. Okay, so the number of electrons, now obviously we need to know the charge on electrons is equal to IT over the charge per electron. So the charge per electron we have to remember is 1.6 times 10 to the negative 19 coulombs per electron. So now I'm going to take my answer for I, which is 2.57 times 10 to the negative 3 amps. I'm going to take my time, which is, for part B, it's 10 seconds. So I'm going to say 10 seconds, divided by the charge per electron, 1.6 times 10 to the negative 19 coulomb per electron. So when I do this in my calculator, I'm going to do 2.57 EE minus 3 times 10 equals divided by 1.6 EE minus 19 equals. So my final answer for the number of electrons comes out to be 1.6 times 10 to the 17 electrons. Now what happens to all my other stuff? So remember, with my units, if I know that, what is the definition of an amp? An amp is what? A coulomb per second times a second divided by a coulomb per electron. My coulombs cancel, my seconds cancel, and 1 over an electron is going to be electrons. So remember, if I didn't know how to do this problem, I could have just kind of looked at my units and said, okay, now the key to this is the charge. Now remember, an electron is actually negative 1.6 times 10 to the negative 19, but we don't need to know that because they just want to know the number of electrons, okay? So the negative sign I don't have to put in here. I just need to know that an electron is, even though it's negative 1.6 times 10 to the negative 19, we don't need to do that because we just want to find the number of electrons, okay? And that's it. So, of course, that was the hardest problem. And it took all the information. Oh, let's do part C. Whoops. Part C says if I double. So I originally, we found out to be, if Q doubles. So Q is originally 9.0 times 10 to the negative 3. So we want to find I. So I is equal to negative Q over T. And I'm just going to put 2 times whatever it was 9.0 times 10 to the negative 3 divided by 3.5 seconds. And that's it. So I'm going to say 9 EE minus 3 times 2 equals divided by 3.5 equals. So it comes out to be 5.1 times 10 to the negative 3 amps. And that's easy. You guys could have done that. All right. So this is number 5. And I wrote really big. All right. Now we're going to move on to practice D. We'll do D6. I don't know why you think the last one's the hardest, but we'll do that one too. All right, so D6, it says the current in a certain resistor is 0.5 amps. So I'm going to write my given. I'm going to write what I want to find. So I is equal to 0.5 amps. It's connected to a potential difference. So potential difference is V. It's 110 volts. What is the current in the same resistor if A, the operating potential difference, is 90, B, the operating potential difference is 130? So first of all, we have to find R. So R is going to be the same because it says a certain resistor. So it's kind of confusing. So the certain resistor is going to have a certain R. So first I have to use this information here to find R. So what I'm going to do first is I'm going to use Ohm's law. V is equal to IR. So R is equal to V over I. So they told me it's 110 volts over 0.5 amps, and I can do that in my head. 110 divided by 0.5 would be 220 ohms. So this 220 ohms of that resistor, that's not going to change because a resistor has a certain resistance, and the resistance in the resistor doesn't change. A resistor is an electrical component, and again, that's not going to change. It's going to be constant. It's not a variable resistor. This is a fixed resistor. All right. Then for part A, it says, so now that we found R, it says now it's changed to a potential difference, or it's changed to 90 volts. So now I'm going to use Ohm's law again, and I want to find the current. So I is equal to V over R. So it's equal to 90 volts over 220 ohms. So 90 divided by 220 is equal to 0.41. For part B, they're going to change the voltage again, and now this voltage is 130. So we just do the same thing again. And it's not, the way they word the problem, it's not really clear. So now I'm going to say I is equal to V over R. So now I'm going to do 130 volts divided by 220 ohms. And that comes out to be 0.59. And that's it. So obviously those two problems were the hardest ones from tonight's homework, the last ones. The beginning ones are easy. You're just either using, in this case, you're using Ohm's law, V is equal to IR. And then in the other ones we used I is equal to Q over T, which makes sense. It's just the definition of current is the flow of electrons, so the charge per unit time. And that's it.